Today we are looking at functions. Okay, we're looking at functions. It's one of another key topic in um, in programming. A very important topic in programming. Um, we want to look at it today, and after we've gone through the theory, we will also look at the projects that is on your LMS, and we'll see how we can implement that particular project. Okay. So functions is, like I mentioned earlier, very, very key or essential when it comes to programming. In other books, they call it procedure. Okay. In other books, they'll use the word methods. In other books, you see the word models or operations. And when we are doing object-oriented programming, one other word that we can use for function is called behavior. Okay, it's called behavior. So basically, functions are like the action parts of your program where the action can be performed, the real action, the real activities, the real operations and behavior of your program. Okay, it's all built into what we call functions. Okay, so if you remember from our session where I gave you an assignment on the libraries to go and look out for 10 libraries in C++ programming and then 10 respective functions under those libraries. Okay, even though I've not come out to inspect that assignment, and I believe you've all done it, you see functions, different functions which perform different operations, okay, in when you apply them to your program. Okay, so let's go through the material. Let me share my screen and we go through the lecture notes. Okay, I hope you can all see the screen.
Yes, sir, we can see your screen.
Yes,
All right.
sir.
Okay, so today we want to look at functions, like I said earlier. Okay, so functions are, or it says in C, a C++ program is a collection of functions. Okay, and one of such function is the main function. So you realize that anytime we are writing a program, we start with our hash include namespace, hash include IOStream, then we start with our using namespace. Then right after that, we introduce what we call the main function. So we start with the data type int main. Okay, then within it, we write our program to perform whatever functionality or whatever tasks that we have to perform. Okay. So today we want to look at function as a topic. Okay, what is function? What are the types of functions that we have? How can we use functions in our program? Today we'll spend time looking at that, and then we'll look at the project as well. All right, so it says it says here that let's imagine an automobile factory. Okay, automobile factory, a car manufacturing factory, when an automobile is manufactured, it is not made from raw materials. Okay, it is put together from privately or previously manufactured parts. Okay, and some of these parts comes from different companies. Okay, so we see a car or even a laptop. It doesn't mean that the company, let's say Nissan, doesn't mean Nissan manufactured everything. Okay, other components of the car that you see, or even the laptop that you see, maybe it's a Dell laptop. It doesn't mean every component of the laptop comes from Dell. There are different components, and these components, some are manufactured by different companies. Okay, so that's just to say that functions are like some of these building blocks, some of these parts. Okay, and they work together to make your program um, solve a problem or function. Okay? Now, uh, we can divide the program, okay, into parts, okay, and manage them based on the parts. Okay. Now, these are all based on some of the programming constructs that we've learned so far. Okay, so the basic data types, the comments, the inputs and outputs, keywords, coming all the way to um, the data, the conditional control structures and the loop control structures. Okay. Functions also is key when it comes to writing your program. Okay. So it says here that there are some advantages to the use of functions. Okay. So it says while you are working on one function, you can focus on just that part of the program, construct it, debug it, and perfect it. Okay, different people can also work on different functions simultaneously. And then you now combine all those functions together to make the program a very robust one. Now, if a function is needed in more than one place in a program or in different programs, you can write it once and then use it many times. Okay, you can write the function once and then you use it many times. Okay, you can write your function once and then use it many times. That's one of the advantages of functions. Now, using functions greatly enhances the program's readability and it reduces the complexity of the main function. Okay, so that's to say that you have your main function. You realize that anytime you are writing a program, we use the main function. Okay, but if you are writing programs that are complicated, that are need the use of other functions, we can't put them all inside the main function. Okay, so it's best to come out with other functions, okay, on their own. Then we do what we call function call. So we'll call those other functions inside the main function, okay, in order to execute those functions. And then I said earlier that functions are often called methods, models, procedure, operations, and behaviors. Okay, so they are like miniature program. They are like a part of the program of a larger program. Okay, and it has some basic components. It has some basic components. Okay, so let's look at the components. First and foremost, the first component here is what we call the return values. Okay, there are functions that have return values. Other functions do not have what we call the return values. So what are these return values? Okay, we'll look at them. Okay, so realize that anytime we use the int main, we do our int main. Okay, today I'll not be able to write because I'm having some challenge where I'm having this lecture from. Okay, so just bear with me. So it has returned values. Okay, that's one. You notice that anytime we do the int main, after writing our program, at the end, before we bring our closing curly brackets, we introduce what? Return zero. Okay, so that's a return value. And the function also has a function name, a function name. So anytime we write int main, the int main or the main there, the int is a data type, which we all know, an integer data type. Then the main there is what we call the function name. So the function name is an identifier. Okay, we've learned about identifiers and the rules governing how to use identifiers. Example, your variable name, function name, class name, and so on. Okay, so your function name is also an identifier. That means it can take any name. However, the name should be a meaningful one, which reflects what the function is doing. Okay. Then we also have what we call the parameters or arguments. So arguments are values that are passed into a function, the values that we pass into the function. Okay, so for instance, let me still use the automobile or a car example. Okay, the car has been manufactured and it's required to move. Okay, take you from one place to the other. Okay, one destination to the other. That's the main functionality of the car. Now, before the car can move, the car needs certain parameter, okay, or certain arguments, okay, which is the value that you pass into the car for the car to move. Okay, so if we take any car, one of such arguments would be, or one of such parameters will be that the car needs fuel. Okay, without fuel, the car cannot move. Okay, so we, in writing the function for the car, we say that, okay, the fuel is the argument which we have to pass into the car for the car to move from one place to the other. Okay, same way we can say a gas. Gas can be the parameter, or maybe electric cars where they need to be charged and so on. Okay, so um, we are just saying here that every function has three basic components. The return values, okay, so it can have return values or it may not have return values, which we'll look at shortly. Then there's a function name. The function name is always constant. Okay, the function name should always come. Now, it's a name that you uniquely give to your function, which should explain what the function is doing. Then we have the set of parameters or set of arguments. Okay, so you realize that anytime we write the function name or int main, you realize that we put in what? A bracket. We put in a bracket, open and close bracket, before we introduce our curly brackets. Okay, so the bracket here is what takes the parameters or the arguments. Okay, and I've given you an example. If you are using a car, a fuel can be the value you pass into a car for the car to be able to move. Okay. All right, now functions are Function names are means by which you can refer to the function. Take note. They are the names by which you can refer to a function. And they are also used when one intends to execute codes defined within the function. Okay, so they are means by which you refer to a function and also execute codes within a function. Every function may, take note, may or may not have return values. May or may not have return values. Okay. And then there are two types of functions. We have the predefined functions and then the user-defined functions. Predefined functions. Sorry, I made it predefined defined. Sorry. So it's predefined functions and user-defined functions. Okay. So we'll look at the predefined functions briefly, and then our main focus will now go to the user-defined functions. All right, so let's look at the predefined functions. So predefined functions, what are they? Okay. What are these predefined functions? All right. So predefined functions, they are also known as built-in functions. They are also known as built-in functions. Okay. Now, anytime I'm explaining functions, I think I like to use Excel to help with that explanation. Okay, because as computer science students, I believe majority of you have used Excel, Microsoft Excel before. Okay, if not Microsoft Excel, Google spreadsheets, and so on. Okay. Now, Excel uses what we call formulas. So formulas can come in so many forms. It could be mathematical engineering formulas, it could be statistical formulas, and so on, physics, and so on. Okay. Now, when you program these formulas, okay, into a particular using a particular language, those formulas now become functions. Okay. So for instance, if we take Excel as I've opened, I believe you can all see the Microsoft Excel.
Yes.
Yes, sir.
Okay.
We're not following it, so you won't go in last one. Did it?
Yeah, Abdul, camera is on.
All right. So when we take I'm not here to watch anyone's face. So, Abdul Malik, please turn off your camera. Okay. All right. So as you can all see, okay, I have Microsoft Excel open. Okay. Now, if you go to the top, the tabs, okay, the ribbons there, you see the formulas. Under the formulas, there's what we call the function library. Okay, so this function library hold a library of a library of functions. Okay, and I think I mentioned it the other time where I use, let's say you go to a typical library, there are shelves where you can, so if you want biology books, you go to biology shelves. If you want maybe mathematics books, you go to mathematics shelves. Then under the mathematics shelves, you see all the books, okay, that fall under maybe mathematics. So different books with different authors. The same way in Excel, when you come, it has in its predefined or inbuilt functions. Okay. So depending on the library you want, or depending on the shelf. So maybe if I come to financial library. I'll see what methods, sorry, I'll see functions here, which are functions that has to do with financial, or you are solving a problem which is financially related, okay, where you need financial formulas, okay, and these formulas have been programmed into your MATLAB in a form of, sorry, into your Excel in a form of what? Functions, okay? So there are a whole lot of them here. If we come to, let me use Math and Trig library, there are functions here. So example of this predefined function, we have what? ABS, which is abstract value. So this will return the abstract value of a number. We have base, so you want to find the base of a number. Now, if you look at it, you see that after the base, it gives you what? A bracket. Okay, it gives you a bracket. And this bracket is taking what? The argument. So the argument that we mentioned, the function name in this context is what? Base. So base what? Maybe you want to find base 2. Okay, so now it's prompting us to enter the argument. If you want to find base of which number, you enter the number. What's a radix? You give the radix. Then you give the um the maximum length. So he said the radix is the base radix that you want to convert the number into. So maybe the number is in a decimal form. Okay, so you want to convert it to maybe base 2. Okay, which is binary form. So you put that there and then you enter the length. So how many zeros are you omitting? The length of the number after the conversion. So you do all that. Okay, so you can see here how it's giving us the value. So maybe let me enter 5 and then the radix, so radix base 2. Okay, and then the length, let me say 8. So that is the argument. Okay, so you can see in the formula, okay, tab, you can see it over here. That's what equals base. So the base here is like the function name. Then you have the 5 are entered as the number, the 2 as the radix, and then the length. Okay, so I want the length to be 8 characters. Okay, 8 characters. Okay, and now it gives me what? The value. So the same way in programming, that is how we have what? Predefined functions. Predefined functions. And the values I've put in here are what we call the arguments. Okay, so it can have, there are functions with no argument. Some can have one argument. Some can have more than one argument or parameters. I hope you are all with me.
Yes, sir.
All right.
Sir.
Yes, sir.
Okay. So now let's look at back to our C++ material and talk more about these predefined functions. Okay. So using predefined functions in programming, in a program. Okay. Now in C++, we do what we call we include the header files. Okay, a typical example of the header files, we've seen it before, is the what is called the IO stream. Okay, hash include. So we include the IO stream, which is a header file. Another example is the IO manip, which we are also seeing how it works, which is also a header file. Okay, then I believe you've done your research and you've seen a lot of them. Okay, so another example we have here is the CMAT. So if you want to use any math function, okay, we use what we call CMAT. Then we have the CC type, which is also used to change the type of a character. Maybe you want it to be uppercase or lowercase and so on. Okay. So there are so many header files or what we call libraries. Okay. And if you remember, I made mention that one of the reasons why a programming language like Python has become very popular in the software development or programming space, or even now in the space of AI, okay, is because of the libraries or the frameworks that it has and the functions that are within it. Okay. If it's not that way, you, the programmer, have to now be taking the various formulas, okay, and now use your knowledge in programming together with your knowledge in that area, maybe mathematics or statistics, and then convert those formulas into functions. Okay, just last night, a friend sent me something to read on. It's a project we are working on, and it has to do with some AI projects. And he wants me to read on, we call it PyTorch. Okay, it's a framework which is used in Python programming for machine learning or artificial intelligence machine learning. Okay, and basically what that is called autograd. Okay, and what it does is that if you are writing a program, okay, in Python, and you use that framework, if you want to perform complex computations, like maybe you want to do some, we all know calculus, you want to perform some calculus computation where you have to differentiate so many times, okay, and by so doing, it makes the whole mathematical equation very complex. This inbuilt framework, okay, which is the AutoGrad, helps you to perform that complex uh, um, differentiation, okay, automatically without you, instead of you writing that, instead of you writing the derivative of your equation over and over again. Anytime you use just that framework, it performs those computation for you without you now doing your differentiation and finding the derivative of x and so on. Okay. So this is one of the tools or the frameworks that makes Python programming very interesting because there are a lot of the frameworks and the libraries that are there now, okay, helps in doing things like AI and so on, okay. Even though when it comes to C++ programming and the rest, they also have their domains in which some of these libraries are very key. Okay, if you've seen the LMS, I've sent a picture on the first part where we looked at the overview of programming languages. I have images there with programming languages and industries and programs that use those languages. Okay, so they all have their domain in which the language works best. Okay, so in this, in what we are looking at now, let me just focus on the mathematics functions or the mathematics library with the mathematics functions. Okay, so um, we have the mathematics functions. Okay, when it comes to C++, some of those functions here, we have the power. Okay, the power function here, what it does is it's like you having a value x raised to the power y. Okay, now you can't write this value in your program straight away. You can't write it in your C++ program unless you are saying that x x times x times x all the way to n, or all the way to xy, something. Okay, so that means you are multiplying x, or let's just say example, maybe 2 raised to the power 3. I'm trying to use my touchpad and it's difficult writing. Okay, so 2 raised to the power 3 is just you saying what? 2 times 2 times 2, as in 3 times. Okay. Okay, so when you say x raised to the power y, it simply means that you are doing x times x times x, y times. Okay, so if you want to do it that way in a program, it will take some time because you need to write it out as a function. Okay, but in this context, there's a math library, which is the C maths. Okay, and in that library, it has the power function. So anytime you want to find the power of a value, say 2 raised to the power 3, just say use the power function PWO into bracket 2, which is your value for x, comma, and then 3, which is your value for y. Okay, so the coefficient and then the exponent value will come in that order. Are we all here?
Yes, I'm here.
Okay, so what you can see here is that it's using the PWO as what? The function name. PWO is a function name. And then 2 and 3, or x and y here, are your arguments. Okay, are your arguments. Now, when we come to the next one, is square root. Okay, now typically you have a value of 4, and then maybe you want to find the square root of 4. You are solving a problem, maybe a quadratic problem where you want to find the roots of the variables. Okay, so in that scenario, you need to use the square root. Now you have square root of 4. You don't have this square root symbol on your keyboard for you to use in your program. Okay, so square root of 4 simply means that what? 4 raised to the power what? 4 raised to the power half, right? Is it half? 1/2. Am I right?
Yes, sir.
Okay.
Yes.
So 4 raised to the power 1/2. That means that what? This 4, you are multiplying it by what? 1/2. Okay. So if we bring this 4 down, we'll get what? 2. Simplify it, we get 2 raised to the power 2 times what? 1/2. The 2 cancel out, and then you get 2 raised to the power 1. Okay, so your answer, square root of 4, will give you what? 2. Okay. 2 raised to the power 1, square root of 4 will give you 2, because this 2 will cancel out. Okay, so now you want to write this in your program. Okay, however, it will require that what you understand how, please stop writing on the screen. The person who just did that, erase it. So it will require that you it will require that you write the function to perform the operation. Okay, you have to write out the function, understand how the square root works, just like I've done a breakdown here, and then use that approach to write the what? The function to solve this problem. Okay, which sometimes will take a lot of time to do. Okay, so C++ has, or the CMAT function, the CMAT library here has the square root function, which is sqrt. That's the function name, sqrt. And then it's taking a parameter, or Malik, please mute your microphone, else I'll put you in the waiting room. Abdul Malik. Hmm?
No, I'm
So if you do that, you would have x as your argument. So we'll put in here square root of what? 4. Okay, and then this will give you the answer 2. So your x in this, the actual parameter here will now be 4. So we replace the x with 4, and then it will give us the answer 2. Okay, then we have the floor as well. So these are all what we call predefined functions. They are already inbuilt. So it's up to you to identify the, how do we call it? Up to you to identify the libraries and the functions within the libraries. Then you know as and when you use them. So imagine you are writing a program where you need to use maybe the power. Okay, you are solving a problem, maybe area of a circle, where you have 2 pi r squared. Okay, now 2 pi r squared, that r squared, how will you write it? Okay, you now write it using the power predefined function. So power 2 pi times 2 times pi times power, where the power is what? Power into brackets r comma 2. Okay, so your x is your r, which is your radius, and then your y is the 2. That's the power, raised to the power 2. Okay, so that is how you use these predefined functions in your program. Please, are we clear? Can you all hear me?
Yes, sir.
All right.
Yes, sir.
Okay. So these are some
sir.
examples. Okay, so we have the function here, the floor function, floor into brackets, x being the argument. You can only use this floor function by introducing or including the CMAT header file. So after your hash include IO stream, you include the CMAT, okay, at the header file. And then what? The return value, what does it return? It returns the largest whole number that is not greater than the number. So floor 4.67, it will return the largest whole number value, which is 45.67. So it will give you 45 because 45.00 is not greater than 45.67. Okay. And what data type does it use? It uses the double data type because it's taking what? A double or a decimal value. Okay. Then when we come to the CC header file, it has a function which is lower. It's lower. Now, what does it return? This will return true. It returns a Boolean value. Okay, it returns true if the value of x that you enter is a lowercase. Otherwise, it will return false. So we realize that in this example here, it said it's lower into brackets h. H is a lowercase value here. This is a lowercase h, a lowercase character. So it will return true because it's saying that what is lower. Okay, and so on, and so many other examples. Okay, and so many other examples. All right. So those are the predefined functions. So there's an example here. I would want you to try it. So you can see in this example 6.1, you can see there that after including the IO stream, they included what? CMAT and then the CC type. So these are all header files or libraries. Okay. And then when you come into the program, over here is using the CC type function, which is to upper. So it will convert this from a lowercase to uppercase. If you go further down, you've seen here that it's using the power. It's using the power here because of what? Because it has included the CMAT library. So now you can use the power to find the power of the values. Okay. So try out this example. So that will lead us to, there's another example here. Okay. So that will lead us to the user-defined functions. That will lead us to what we call user-defined function. Okay. Now, as a computer science student, it's very, very necessary, very important for you to understand functions and to be able to write functions. Okay. Yes, there are predefined functions you can use, which makes works easier. But there are times you come across certain problems and there are no functions, there are no predefined functions to use. So what do you do as a computer science student or as a programmer? It's up to you to understand the task and then use your knowledge in functions to translate that particular task into a user-defined function so that you can use it or reuse it in your program. Okay. So it says here that C++ does not provide any function that you would ever need. Does not provide every function. No language provides you every function you would ever need. Okay. So what will happen? It is up to you as a programmer to design your own user-specific functions for certain problems. Okay, to design your own user specific functions. Okay. Now, how do you do that? There are two main categories. The first category are value returning functions. Two types of user-defined functions. There are functions that are value returning functions. Okay, so these functions are functions that have the return type. So you see them anytime we use them at the end of those functions, you see that we write the return. We return something. Okay. Now these functions return a value of a specific data type using the return statement, which will return, which we'll explain shortly with the examples we want to look at. Then we have the second category, which is called the void functions. Void functions. Okay, so someone was asking me, I think last week and previous lectures, some people were asking what the void means. Okay, now anytime you see a function name with void in front, what it means is that those functions they do not have return types. So in those functions, you don't see us write at the end of the function return something, or we don't use the return statement. Okay, we do not use the return statement. So those are the two main categories of the user-defined function. Okay, all right. Now let's come to an example that we've seen for some time now. This example has to do with if two numbers, which one is larger? Okay, we've seen these examples, two numbers, which one is larger? Okay. So we want to go through this example. The code is already there, so I'll just go through it with you after this. Then we'll move straight to the project, okay, and look at how we can solve that project. Okay, so the problem here is to determine the larger of two values. You have two values. You want to determine which one is larger. Which one is larger? Okay. Now, ideally, we would have started with our ideally, we would have started with our hash include namespace, using namespace, okay, hash include IOStream using namespace and so on, and then move all the way to the main, move all the way to our main method. Are we all here?
Yes, sir.
Yes, sir.
We would have moved all the way to the main method. I remember the example we did the other time with the if else. Okay. If you've forgotten, go back and watch the last Zoom session we had. The video is online on the if else. We looked at an example like this, a greater of 2. I think we did 3 values instead of 2. Okay. So the same example here, but this time around, we are supposed to use what? A function to determine which of the 2 values, okay, is greater. So instead of going straight to our main method to handle that, instead of going straight to the int main to handle that, this time around, we are introducing what we call a user-defined function. A user-defined function here. Okay. Now look at it carefully. First, we start the function with, in this context, this is a type of user-defined function which follows the first category. The first category, we said that what they have a return value. Okay. So over here, we say int. We are using int here. Now it can be any data type. Please take note. Okay. But the return value would determine the data type you have to use. If whatever function you are writing will require that you return a decimal value, then you use a double data type for the function. Okay. If it means you are going to return a float, a decimal value, you use a float. If it's a character value, you use char and so on. Okay. So this will return an integer value. You have 2 numbers, maybe 4, x is 4, and then y is 6. We want to see which one is greater. Okay. X is 4, and then y is 6. We want to see which is greater. Want to see which one is greater. Okay. So the first thing, you should know the data type that you are using. That's if you are going to have a return value. Now, the next thing you need to know is give it a function name. Okay, let me change the color so that you can see what I'm talking about. So the next thing is to give it a function name. So the function name, I'm using the green to underline it. Okay, so you can see the function name, larger value. Okay, so the function name, like I said, should speak to what the function is going to do. Sometimes you can say find larger value or get the larger value. Okay, So just give it a name that if anyone sees it, the person can tell that, okay, this is what the function is doing. Okay. Then the next thing we have there is our brackets, open and close brackets. So in this bracket, we have our arguments. And the arguments are the two numbers that we are going to enter. Okay, but in the argument, we use a dummy argument, where this dummy argument can be any variable. In this context, X and Y. Okay, we don't know the numbers yet. We don't know the values yet. We don't know the numbers yet. So we use X and Y. So we say int X and then int Y. Okay. Then now we come into the function itself. And then we say that int maximum value. We declare a variable and name it maximum value. Okay. Maximum value, because that is what is going to return what the larger value is. So we introduce our conditional statement and say that if X is greater than or equal to Y, we should say that what? Maximum value is equal to X. Else, maximum value is equal to Y. So we've learned about conditions. Okay. Maximum value is equal to Y. Okay. That means that it will first check, okay, is your 4 greater than or equal to your 6? If you say your X is 4, your Y is 6, it will check. Okay. So in this context, it's going to give us what? Maximum value will be what? It's equal to which one? Who can tell us?
Y.
Y. Thank you. Maximum value will be Y. Okay. So maximum value. So what do we return? We return the maximum value. So we declare the maximum value here. We use it here. Okay. And we use it here because we want to get that maximum value. Now, what we are returning is the maximum value. So from this example, we return Y. We will return Y. Okay, based on the example we have here. Okay. Now, so that is how you write your user-defined function. In this particular example, it's a function which has a return value. Okay. Now, if the function doesn't have a return value, instead of using the data type here, we rather use void. Then with the void, there will be no return value. Okay. But this we are using int, so there will be a return value. Now it says here int main. Now we are done with our function, user-defined function. Okay. Next thing we do is now we come to the main function. Now the main function is where you execute the program. Without the main function, you can't execute the program. So even though you do your user-defined function, you still have to call it inside the main function. The name is function call. You call it inside the main function. Okay. So here inside the main function, it says what? Int A and B. So enter A. So enters the value for A. So let's say our A here is 4. Enter the value of B. Our B here is 6. Okay. So it's using these two variables to replace your X and Y arguments here. So this variable A and B are now going to hold the actual value that will be used in your function. Are you all with me?
Yes, sir.
And
Yes, sir.
Yes, sir. Yes, sir. Say yes, sir.
all right. So now let's look at how the function call works. Now the function call simply means that, okay, you have defined a function. As we can see here, the function has been defined. Okay, so what do? We are calling it. Okay, we are calling it in here. We are calling it. Now, how do you call the function? Now, you call the function by first introducing the function name and then assigning the actual values to it. What are the actual values? We are prompting the person to enter A and B. So if the person enters A as 4, it will do 4, comma y. Y is our B value now, which is 6. Okay, so this is what we call the function call. So we are calling the function name, which is what? Larger value into brackets AB. AB here is the actual value. So A, you entered 4, B, you entered 6. Okay, so it's going to do the comparison. Is 4 greater than or equal to 6? This is what? False. So if it is false, it will come to the else. Okay, meaning that 6 is rather greater. It will return y, and the y is the same as our what? Our b. Y is the same as our b, which is 6. So it will return the value 6. Okay, just like we have here, return y, where y is equal to 6. Okay, so now let's look at the output of what I've just explained, which is down there. Sorry. Okay, so over here, it's saying that what you've entered A as what? 3, and then B as 4. So the larger is 4. Okay, the larger is 4 because you have saying, so this is the word, the larger value is, that's the same thing, the larger value is, then this 4 here is based on what? The function call that we've introduced. Okay, all right. So that's it. There are some more examples here. I'd want you to try it and also try this exercise. Okay, want you to try this exercise. Now, this exercise is saying that write a function which is an integer. So this is a function name, power. The function name is integer power. Then you have your argument as base and what? Exponent. Okay, and this returns the value base raised to the power exponent. So if the base is 2 and the exponent is 3, sorry, the exponent is 3, that's like you saying 2 raised to the power 3. Okay, and that 2 raised to the power 3, you can break it down. So it's giving us example, which you can break it down to what? 2 times 2 times 2. Okay, so now look at the assumption here. It said assume that exponent is positive, and then you have a non-negative integer. So your exponent is 3 is positive, and your non-negative and a non-negative integer, and then base, a non-zero integer, and then the base is an integer function, which is a positive, an integer. It's an integer function, okay, with the function name that is the power, integer power, and should be used, and then use the for or while to control the calculation. Now take note of this. It says, do not use the math library function. We all know the math library function is talking about, right? I hope you all know the math library function is talking about. Who can tell
Yes,
us?
sir.
Yes, please.
No.
C mark.
No, it's talking about the math library function. What function is that? We've talked about it already. What function is
The
that?
predefined functions.
What is the exact, the power function? PWO function.
The power function.
Yeah. So it's saying that don't go and use PWO. Don't go and use that function. That one is predefined. Don't go and use it. Rather, you are supposed to do a user defined. This is how the power works. So you as a programmer, and you know how power works, okay, use that to write this function. Okay, so I want you to do that when we meet next week. If you've done that, you show it to me. Okay, and then I award you some marks. Hello.
Sir, please can you print it?
So I'm saying that this exercise here, go and try it on your own. Okay, write out the function and come and show it to me next week. You can do it on your laptop. You can do it on a piece of paper.
Yeah, please.
Yeah, please, after
The exercise is on the page.
It's in your, go through your handouts, you see it.
sir, please, after writing, can you print it out?
Print it out, as in,
After writing your program,
can you print what out?
what you've written.
When you say print it out, is it
A
using
hard
the
copy.
C? Oh, you can
Yes.
do it in your notebooks. Your notebook. Once
Oh.
you understand what you've done, you can do it. If you have your laptop too, you can do it on your laptop and bring it. So those of you who bring your laptops to school, you can do it in your laptop or write it down. All I want to know is you understanding how the power function would work without the use of the library function. How you yourself can write that program to execute the task. Okay. All right. Any questions so far before we look at the project? Any questions on function so far? If you have a question, just raise your hand. And then if there's no question, we'll look at the project quickly. All right, Benedict, and then Roger. Okay, Benedict, your hand is up.
Yes, sir.
Yes.
Yeah, sir, please, I wanted to ask that with the first example that we saw,
Yes.
like what will happen if you after the hashtag include iOS stream, then the using namespace, what will happen if you bring the int main before you writing the user defined function to determine the larger of two values?
It will still work.
Okay.
It will still work. But ideally, you can do what we call, we'll do it I'll introduce that to you in the project. So you see how you can also do that. So you can actually define your function down. I'll show you how to do that. You define it down, write your main. When you finish, you can now come in, write the function to perform the actual task. Okay. So that's another way in which you can do it. But whichever way, you bring your main first before your user-defined function, it will still work perfectly.
Okay.
Yeah.
Okay, thanks, sir.
Okay, welcome. Eric Odro.
Yes, sir. Thank you, sir. So please, my question is on the first one. When we define the int larger value into brackets, int x, then the int y.
Yeah.
Now, when we came to the main function, the int main, we also define another a different variable, that's the int a, then the b. So my question is, can't we also use the same x and y instead of the a and the b?
You can how do I put it? You can use it, okay, but just not to make it how do I put it? just to make it such that the program can identify the type of argument, okay? Because there are two types of arguments. There's the
Yes, sir.
dummy argument, which is what you use in the over here, what I've circled here. That's the dummy argument, okay? And then we have the actual argument, okay? So this is just to differentiate your actual argument from the dummy argument. Is it a TV you are watching or something? If you can reduce the volume, it's interfering, or you mute yourself.
Okay, sir.
Okay. So we have the dummy argument, which is the X and Y. And then we have the actual argument. Okay. Ideally, you remember what we did in Excel. I entered the values directly. Okay. Another way I would have done that would have been to select the cell in which those values are. Okay. So the A and B is the actual argument. Okay. So instead of even doing A and B, I would have just gone straight forward and say A is equal to 4 and B is equal to 5, and just do a larger value into bracket 4,5 or 4,6. Okay.
Oh, okay.
But you separate it because they the program needs to understand what values are going in there, even though there are times where you put the same variable there. It doesn't give you any issue, but it's always best to have different values declared in the main to represent the actual parameter. Is that clear?
Okay, sir. Thank you.
Okay.
And
Okay.
so there's another one too, please.
Okay. So we'll take this question and then the last question, then we move into the project.
Okay, thank you, sir. You see, in our previous lessons, we were dealing with the C out and the C in, where maybe you want the user to enter his or her name. If you enter your full name, it appears, or the first name appears. So I think I was watching a video and they use get line. So I wanted to know that get line, that is that one to a user defined function or it's predefined? Because when the person used the get line, it was able to execute the full name.
The get line is not, I think you've asked this question before, the time we're doing the input and output. Okay. The get is also, it's predefined. I'll not call it, it's works just like the C out. Okay. It's also one of the manipulators. Okay. Just that when you use that one, it's able to separate if you are taking, if you are accepting inputs, let me put it that way. You are accepting input where you need to space out, you are writing more than one word. You get it? You are writing more than one word. So that means if you are writing more than, let's say, a sentence, you are getting inputs, but your input is coming in the form of a sentence, not just a word or a character. Okay, so in that context, you use the get line, and what it does is it gets the entire line. Because if you are writing a sentence, it will be a line of statement with spaces in between each word. Okay, so that get line is more like a function, or we can say a manipulator, which gets the entire line of your statement or the input you want to include in your project, in your program.
Thank you very much.
Okay, you're welcome. All right, so let's move to the project, and then we have like 30 minutes to look at that. the main emphasis will be on the coding parts, okay, which I'm going to take you through. All right, so let me switch my screen. Can you see my screen?
Yes, sir.
It's on the
Yes,
project.
sir.
It's on the project, right?
Yes.
Yes, sir.
Yes, it is. Yes, sir.
All right. All right. So let's look at this project. This project is a simple bank account system. It says the goal of this project is to create a simple bank account management system in C++ that allows users to perform basic banking operations. So what are the basic banking operations? You can deposit some money, you can withdraw your money, you can check your balance. These are the basic, even though there are more functionalities to a banking system. But we want to see the basic one and have an idea of how we can use some of the programming constructs we've learned to implement this task. Okay. So as the project is saying, the banking operations. So we can replace the word operations with the banking functionalities. You get me? We are looking at functions, so we can replace the word operations with banking functions or functionalities. And those functions are deposit, withdraw, and then check balance. Okay. Now the program will use functions to modularize modularize the operations and control structure to handle the inputs and decision. Okay, so it's going to use control structure to handle the inputs and the decision. All right, sorry, let's continue. So we are going to use the functions to handle the operations, which is the deposit withdrawal, and then the checking of the account balance. Then we will use the control structures to handle the user inputs and decision. Okay, user inputs and then decision. Okay, so what are the learning objectives of this project? So you should be able to use the function in the program, apply control structures, that's the if, else, and the loops to make decision. You should be able to use input and output operations, and then develop an algorithm and flowcharts to plan the program. And these are all things we've discussed so far. Okay, so even if we decide to end the semester today, okay, and you see a project like this, we should be able to answer it because this project has tackled the basic things you need to know about programming. Okay, or this objective has handling the basic things you need to know about programming. So what are the deliverables? What am I expecting? An algorithm, a flowchart, and then a C++ program. And like I said, your exams will follow a similar format. That's the section D of the exams. Follow a similar format. I'll give you a project for you to handle. Okay. So The algorithm, I have it here. I'll take you through it, but I want you to do the flow chart, draw the flow chart, and then bring it next week. So next week we are submitting two things: the flow chart to this project, and also the question in the function, the one you are supposed to look at, which is the exercise. Sorry, the exercise on the power, integer power. Okay, so either you do it on your laptop or you do it in your notebook. But for exam purposes, especially with the flow charts, you are expected to draw it. You are expected to use IO, draw.io to implement it. Okay. So, but with this one, if you can do it on your laptop or in your notebook, that would be great. Okay. So let's look at the flow chart. Sorry, let's look at the algorithm first. So the first task here is for us to start the program. Okay, we know that the first step is always start. So we have here start. Then it says initialize the bank account to 0. So your initial account, in fact, when you go to a bank, you go and open an account. Your account initially is 0. Okay, but in the banks in Ghana, you'll be required to do what? An initial deposit, maybe 50 Ghana cedis or 100 Ghana cedis. Okay, but as at the time you are filling the forms to open the account, your initial balance will be what? 0. So it says initialize the account to 0. So that's like you saying account is equal to what? 0. Okay. Then the next one, it says display a menu of options to the user. This is like you using mobile money. Then mobile money, you enter your star, whichever code it is, hash, you log in, and then it will give you option. Maybe first one, Momo subscriber, Momo pay, whatever option. Okay. So it gives you that option and then you choose from. So our program you are writing is following a similar approach. Okay. So it said display a menu of options for the user. So the user, if the user wants to perform a deposit, we choose 1. If you want to do a withdrawal, you choose 2. If you want to check balance, you choose 3. If you want to exit, 4. Okay. Now, so after the user has entered the option, so prompt the user to select an option. So maybe the user selects 4. Or let's say 1. The user selects 1. Okay. Prompt the user to select. If the user selects 1, you use a control structure, a loop, or maybe an if-else statement. Okay. You use an if-else statement. Let me put it that way. Okay. So, and say that if the person selected 1, right? If the option is 1, that is what? Deposit. Then it should do what? It should add the amount the person wants to deposit to the balance, which is 0. And then it should return the new or the current balance. Okay. Else, if the option the person chose is 2, then it should subtract 0. It should subtract the amount the person wants to withdraw from the balance. Okay. Now, there's a caveat here where already the person's account is 0. So you can't go and be withdrawing from an account balance which is 0. So you should put in a statement that will say that, oh, insufficient funds available. Are you with me?
Yes.
Okay, so we are solving the problem. So you are thinking through the problem and putting down all these scenarios in a form of an algorithm. Okay, so that when you are now implementing the program, okay, the thoughts just flow and then you implement it in the language, your choice. Now, if the option the person chooses, else if the option is option 3 is what? Check balance. Okay, the person chooses option 3, then it should display what's the current balance. Else option 4 is what? Terminate, so exit the program. So if he exits the program, this will move the person to what? Step 7, or you can say go to 7. You saw the way we have it in our lecture notes. There's a handout where we saw the go to and all that. So go to what? 7, step 7, where it will end the program. Okay. Now, then there's step 6. Step 6 is going to repeat steps 3 to 5. Okay, so in this context, you use a loop. That means that, and if the person chooses step 1, 2, and 3, okay, and does any of these operations and still wants to perform another operation, then it should take the person all the way to step 3 to choose another option. Are you with me? You get the whole scenario of the algorithm.
Yes, sir.
All right, so that is how the algorithm will look like. Now, with that understanding, that has also been explained here. So since I've done the explanation already, I'll not go back into it. It's explaining how the program will be. So now let's go to dev C++ and write out this program. And let's move to our dev C++ and then write this program. Can you all see my screen?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yeah.
All right, so the first thing we'll do here is to introduce create our source file, and then we introduce the or include our IO stream. Okay. So source file, then hash include. Okay, so if you have the project file downloaded, you can have it side by side as you flow with the program. So IO stream, and using namespace std. Now, we have been told to what? To introduce a function. So first, we introduce a function that will display the menu. Okay, we introduce a function that would display function to display the menu. Okay. So that function, I'll call it void because we are not returning anything. So I'll call it void. And then we'll say that void maybe display menu. Okay. Now this particular function is not taking any parameter. Can you all see that? It's not taking any parameter.
Yes, sir.
Okay, it's a void function, which also means there's not going to be a return type. The display menu here is a function name. And once you even see this, you can easily tell that, okay, this is what the program, this part of the function, or this is what the function is doing. Okay. So I'm going to use my cout, and then I'll say cout, sorry, lowercase, cout. Let me use my escape sequence. I believe you've read on this escape sequence thing. Last week, some of you were using / instead of \. Okay. So cout menu. Okay, I'm going to paste it and then edit it as I move along. So the first one is, I'll put here 1, deposit money. Then this will be 2, withdraw money. Then 3, check balance. Then 4 is what? Exit, right?
Yes.
Exit. Okay. And then we have 5, which is cout. So let me put over here a prompt and say, enter your choice. You get me? Are you following?
Yes, sir.
Okay. So first it will display the menu. Okay, show you the 4 options, and then it will enter your choice. I mean, they say enter your option. Okay, or choice, whichever word you want. Now we realize that this is a function. Now, if I run this program, it will not work. Let me run and save it. Let me save it as project 1. Okay, so he said invalid pre-processing #include. Did I spell it well? Oh, I made a mistake. So #include. Okay, let me compile and run again. Okay, now it said, okay, expected a semicolon. So I put that there. I think I omitted that for all of them. Compile and run again. Oh, sorry, I omitted it here as well. All right. So this program is not running because we have not introduced the main method or the main function yet. Okay, so the program is not going to run. Okay, but I'll just do something here briefly. Introduce the main method and then see how the code would appear. Okay, so let's go into our main. You know, we have 3 more or 4 more functions to create, or 3 more functions to create. So let's introduce our main. So int main, let me close this. Int main. Now inside our main, I'll introduce a variable and say int option. Int option, because we are telling them that what? Enter the option, right? So we say int option. Then I'm going to use a do while loop. It looked at do while loop the last time. Okay. So I'll say do, what do I do? So do, then I'll now come and call this method because we want to display the menu. Okay. So int option, let me put a comment here and say displaying the menu. Okay. So you know that the do will perform the task first before it will implement the switch. Sorry, it will implement the while. Okay. So do, what are we doing? So here I want to call the display menu function. Are you all following?
Yes, sir.
All right. So I've told you the function call, you only introduce the function name and then the curly brackets. Sorry, the function name and the brackets. So I'm going to copy this display menu function and then come and paste it here. So what I've done here is that I'm calling the function. Okay, I'm calling the function. Are we all here?
Yes, sir.
Yes, sir.
Yes, sir.
Let me put my return 0 here. I'm calling the function. So let me run this. I hope the while will not give us an error. Okay, so it's expected a while. So let me put the while here. So we say while into brackets choice. While we use option, right? So enter the option. So while the option is not 4, it's not equal to 4. Okay, so we are prompting the person to choose what options. So while the option is not option 4, the loop should continue. The loop should repeat itself. But when the person selects option 4, which is what? Exit, the loop will what? End. So while the option is not option 4, first we are telling the person to enter the option, int option. So if the option is not option 4, the loop will what? End. Okay, the loop will end. If the option is option 4, the loop will end. But while the option is not 4, the loop will repeat itself. Okay. Yes, Paul, your hand is up.
Sir, please, good afternoon.
Yes, afternoon.
Please, can we also say that while option is less or equal to 4, less or equal to 3? And question 2, after the enter your option, can we come down and say C in option?
Okay.
Into brackets 1, 2, 4.
All right. So let me address your first question. You said what? While can we say that option less than or equal to 4? Yes, we can do that. However, under one condition, if the person ends up entering a negative value, okay, it will still work anyway. Okay. If the person ends up entering a negative value, okay, that will bring an error. Or not necessarily in that case. If the person ends up entering, let's say 5, okay, 5 is less than 4. Now we are going to use a switch case to write the various options. Okay, so maybe when when we write the switch case, then I'll use it to explain your first question very well for you.
Sir, please, 5 is rather bigger than 4.
Yes,
But
I know. That's why I'm saying let's get to where we write the switch case. Then I'll use that to explain why I mentioned 5.
Oh, okay.
You get it? Okay. So the other question too is what about rewriting the C in after line 10, right?
Yes, please, sir.
Okay. We can do that. But the issue or what will happen in that context is that we need to put the C inside the loop. Okay, we need to put it inside the loop. It will still work anyway, but in the right A, we need to put it inside the loop, preferably maybe after this, when we call the function, then we'll put it there. Okay. When we call the function, we could put it there. But when we put it here too, it should still work. It should still work. All right, so let's run this, compile this, and see if there are no error. Okay, so the while, okay, there's supposed to be a semicolon here after the while. Let me run it again. All right, it's giving us an output. Okay. Now let me show you what is happening. Can you see the output?
I'm also facing the same thing.
Yes,
Perfect.
sir.
So
I am
this
also
is infinite. Okay, infinite because we've not, you know how the do while loops work. It will activate what is in the do until the condition of the while is met. But in this context, we've not specified the condition of the while, okay, inside the do yet. So it will be infinite. It's going to repeat itself over and over again. So now let's go back into the code and then specify the conditions for which our while loop should stop. Okay. So after the display menu, after we've called the function for display menu, we are going to use our cin to accept the option. So cin option. Okay, cin option. So the person will enter the option. Now, after entering the option, we use if else or switch case. Okay, in this context, I want us to use the switch case so that you understand it more. So the switch case, we say here that switch into brackets option. Okay. Then curly brackets come, open and close curly brackets. Now in here, we are going to put the cases. So if it's case 1, that's option 1. What should you do? You should what? We are going to put a function there which will execute. We've not written those functions yet, so I'll put it there. Then if it is case 2, so case 1 is what? For it to display, for it to perform deposit. Case 2 is for it to perform. So let me just put a C out here. We'll come back and edit it. Case 2 is deposit. Then after that, you do what we call break. You break. Okay. Case 1 is deposit. Case 2 is withdraw. Case 3 is check balance. And then case 4 is what? Exit, right? So we can put here exiting the program. Are you following?
Yes, sir.
So if the person enters the option, so is it option 1, option 2, option 3, option 4? The person enters option 1, it will do the deposit. Over here has to be a function. We've not written that function yet for deposit. Withdraw, case 2, case 3, check balance. We've not written all these 3 functions yet. Okay, so I just want you to see how the program will work before we move to write those functions. Then case 4 will be what? Exit the program. So they tell you exiting the program. Now the case 4 is for the loop. So we are saying that if the option is not one of this, that's 1, 2, 3, and the person enters 4, it will exit. Okay. Now the question is that what if we use less than, right? Okay. If you use less than, yes, it will still work anyway, or less than or equal to 3 instead. Okay. Sorry, less than or equal to 4. If you do less than or equal to 4, what will happen is that even if you do 4, the loop will continue. Even if you put there 4, the loop will continue. Okay. But if you do it less than 4, okay, what will happen is that the loop will continue while the value is less than 4. Okay. But if the value is 4 or greater than 4, the loop will stop. You get it? Now, another option, the reason why we are using the not equal to 4 is because someone can enter 5, 6, and so on. Okay, so we need to capture it so that if the person enters 5, it could be a mistake. If the person enters 5, we don't want the loop to exit. The person who has a question, is it Paul?
Yes, sir.
So if you go and do it less than or equal to 4, and the person enters 5, okay, we don't want the loop to exit. So what do? We put there a default statement. So that maybe the person enters 5 by mistake. So we put default there and say that maybe invalid option. Invalid option. Try again. Or please try again. You get it? Okay. So because of this, we'll do it such that, but if you do it greater than, if you do it option less than 4, that means that any option that is less than 4, any option that is less than 4 will be handled based on this case 4. Any option that is greater than 4, so for instance, a person enters 5, 6, 7, 8, 9, 10 going, it will be all executed based on case 4. But we want it to only end if and only if the person enters 4. That is when they want the loop to end. You get the reason why we are using the not equal to 4. You get the logic now. So that if the person enters 5, 5 is an invalid option. So we don't want the program to stop. Rather, it should do what? It should prompt the person to try again. Okay. So if you go and do it less than 4 and the person enters 5, the program will end without going to the default option. But we want the program to only end when it is equal to 4. Do you get me?
Yes, sir.
Okay. Emmanuel, your hand is up. We've
Sir,
entered
please.
1 o'clock. I need to be wrapping up because I have another
Sir,
meeting
please.
at 1. Yes, Emmanuel, go on.
Sir, please, thank you for the opportunity. Sir, please, I wanted to ask that. So, sir, imagine somebody enters a value other than 4, that is 5, 6, 7, 8, and the program tells the person invalid option, try again. So, are we to write another code that will literally take the person back to the menu page? Hello.
All right.
Hello,
So,
sir.
Emmanuel, we are
Yes,
looking
sir.
at loops.
Yes, sir.
Yes, so, from what we learned last week, we don't need to write any other code that will take us to the main page.
Okay.
Everything is being handled here. So once whatever you've entered, whatever option you've entered, this switch case is the one that will determine what it will execute.
Okay.
So if you enter 4, it will do a deposit. If you enter 1, it will do a deposit. If you enter 2, it will do a withdrawal. But even after the withdrawal, it will prompt you, even after performing that, it will prompt you to enter the option again.
Okay, sir.
So this will repeat itself because this display menu, the display menu has the enter your option. This display menu function here, it has what? Enter your option. Okay. So once this display menu is inside the do loop, the do while loop, it will keep repeating itself unless the option you entered is equal to 4.
Okay, sir.
So you don't need to write any
Thank
other code again. It will just be repeating itself until your option is 4. Then it will exit. Okay.
Okay, sir.
All right.
Okay,
So
sir. Thank you,
let's
sir.
run this, and then what's the name? I think Wisdom. Your hand is up. So let's run this. So whilst it's running, Wisdom, you can ask your question.
I already tried writing a program for the project, except that I wasn't using the voice, the user-defined function, and
Okay.
then it running all right. I just want to know if that's also fine. I use the file loop for it, and it works perfectly well.
What did you use?
Use the file loop for it.
I didn't hear you.
So
Can you
I said I already tried writing a program for this project, the banking system project. Yeah. After declaring the variables deposit, initializing the balance to 0, I use the for loop.
You use the for loop.
Yeah, the file loop.
File loop.
Yes.
Are you saying for loop or file
He
loop?
said wow loop.
Wow. Oh, okay. Okay, sorry. I was hearing file loop. Okay.
After that, I use the switch keys for the menu, and then it works all right.
Okay.
I just wanted to know if that's also fine.
Oh, yeah. Once it's implementing the task, I keep telling you that there's no one way of writing a program, even your algorithm. Okay. So once it's implementing the program, Charlie, you are good to go. The only thing for this level, you are okay. For higher levels, you need to look at I keep saying you need to look at the time complexity and the space complexity. Yes, two people can write a program to solve a problem, okay, but the way you use your loop and your if-else statement will determine how long the program will take. In terms of it will determine the complexity of the program, even though we are all getting the same output. Okay, but for now, once it's running, you are getting the desired output. You are good to go. Okay, if you learn level 200, learn data structures and algorithm, which is looking at the analysis of algorithms, where we look at the time complexity. Okay, what's the running time? What's the complexity of your code, of your function or your algorithm? Then based on that, we'll tell whether the code you've written, whether it's a good code or it's a bad code. Do you get it? But for now, whichever method you use to get the job done, perfect. Do it. So I'm not saying mine is perfect. I'm not saying yours is perfect or not perfect. But once we are getting the desired output we want, then thumbs up. You get me, Wisdom.
Yes, sir. Thank you.
All right. Okay. So let's try out the code. So for instance, if I enter option 4, what does it say? Exiting what? The program. So with this option, I can only see my menu again when I rerun the code. So let me rerun it. So I have to rerun the code. Then now maybe enter option 1. So when I enter option 1, so while your option is not equal to 4, you get it. So while this option I've entered is not equal to 4, that means the loop will repeat again. Okay. So when I enter it, it said what? We said it should print out what? Deposit. So it's printed out deposit. Okay, then it's showing me the menu again. Enter option. Now I enter option 3. What does it say? Option 3 is check balance. It has shown me check balance. Now enter your option. So now let me enter option 5 and let's see what it will say. Option 5, it said what? Invalid option. Try again. So I enter option 4. I enter option 4 and then it exits the program. You get it? Okay.
Yeah.
All right, so I'm going to do the deposits. No, I'm going to do the withdraw function with you. Then I'll leave you to do the check balance function. Okay, I have a meeting at 1, but let's pass 1. Okay, so let's see how it goes. So quickly, let's look at the function for. So I'll come before my main function, and then I'll write a comment there. Let's say withdraw function. So withdraw function or a function to withdraw the money. So I'll use void withdraw. Okay, or I can say withdraw money or withdraw, whichever one you want, into brackets. Now we are going to give it a parameter. Okay, now if you want to withdraw, definitely there should be a balance in there for you to withdraw, right? Yes or no?
Yes.
Okay.
Yes, sir.
So the balance will be your parameter. So I'll say float balance. Now we learned in pointers the use of the ampersand. I use it to get the location of the value. Okay, so we can use it here. Let me just use it here so that you appreciate what is going on. Or we can, okay, let me use it without it. And let's go on. So we enter, we say float amount. Okay. Float amount. Then we will prompt the person. So this is the amount you want the person to enter. So we use cin and say enter amount to withdraw. Enter amount to withdraw. So we are expecting the person to enter the amount. It should be in this double quotes. Then we use cin for the amount. Okay. Now we are saying there's a caveat here in the sense that if there's no money in the account, how can the person withdraw? Okay, if there's no money in the account, how do you expect the person to withdraw? Okay, so it should give something like insufficient funds. So we say that if I want to use if I use the ampersand, there is another way, but let me make it much more simple for you. So for you to withdraw, your amount you are entering, are we all here? Your amount you are entering should be less than your balance. Less than or equal to your balance. Now, in some banks, it should be even less than your balance. You can't even withdraw. You have to make sure you have maybe 10 CD or 100 CD in your account. Okay. So in that context, to be less than, but this one, let's make it the fact that it should be less than or equal to the balance. So your amount, if your amount is less than or equal to the balance, okay, what should we do? We should let's take note of the brackets. Okay. So we should say that balance is equal to balance minus the amount. You get it? Balance is equal to balance minus the amount.
That's it.
So now we display withdrawal successful. And then we say new balance
You will check on
then we'll put here the balance. Let's use end line instead, end L. You all see that? So if the amount is if the amount is less than or equal to the balance, we should deduct the amount from the balance and then show the new balance. Okay. Else what do we do? Else we say that you don't have sufficient funds. So see out and say see out, then we say in
Insufficient fund.
you get it. So we've written a user-defined function here. So first, we'll take in the balance. Now, when we take in the balance, we check is then we look at go into the withdrawal function. Okay, because the balance. So it's like you've gone to the ATM. When you go to the ATM, you enter what you enter the amount you want to withdraw. But inside the ATM or the machine already knows your balance. Okay, so it takes that and then performs the transaction. So your amount you want to withdraw should always be less than or equal to your balance before you can withdraw. If it's more than your balance, it will tell you that what's insufficient funds. Okay. So here our balance, let's just give an amount to the balance. I want us to do, after the mid-semester exams, I want us to look at the other parts of the project. Because of time, we can't do all of them today. So I'll just do only the withdrawal, and then we look at the other parts in class after the mid-sem next week. So I'm going to introduce float, save float, balance equals, let's say 100, so that we can perform withdrawal. Okay. Now, when we come to the switch case, option 2 is for withdrawal. So this time, we are going to call the withdrawal function here. Okay, we are going to call the withdrawal function, just like we call the display function. We'll call the withdrawal function, and we call the withdrawal function based on what? The function name. Okay, function name, and then we'll put in here, I'll paste it here, that's withdraw into brackets. So you see that it's asking us for what? Float balance. So I'll put balance here. So now let's compile and run and see if we can perform withdrawal. Curly brackets. Am I missing out something? Okay, yeah, another curly brackets. And then a semicolon, I think. Or one, okay, just one curly brackets and a semicolon. So option 1 is saying we should make a deposit. Option 2, withdraw money, check balance. Okay, so the function we wrote has to do with option 2. So let's select option 2. Okay, now it says enter the amount to withdraw. So I enter 50. So it will check, is 50 less than 100? Because we put 0, we put 100 as the balance. And the amount is 50. Is 50 less than 100? Okay, so 50 is not less than 100. So it says what? Withdrawal successful. New balance is what? 50. Okay, then it comes again. Enter an option. I want to withdraw again. The 50 that I withdrew, I'm not happy. So I want to withdraw 100. So I come again and I enter amount to withdraw. I enter 100. Now what does it say? Withdrawal successful. Okay. All right. So it's doing this because the balance is constant. Okay, that's why I'm getting this. But if we were to implement, so it's telling me the balance is what? 100. But we all know that what? We've already removed 50 from the 100. Are you all with me? Are you all following?
Yes, sir.
Yes, sir.
Yes, sir.
We've
Yeah,
already
sir.
withdrew 50 from what? The 100. Okay. So we are supposed to be left with what? 50, right? But when we come to withdraw 100 again, it's giving us our balance is 0. Okay. So this is where
So it's supposed to give you insufficient fund.
it's exactly. It's supposed to give
Okay.
a sufficient fund. Okay. So this is where I'll put the ampersand before the balance. Okay. So that it is not looking at the 100 that I've entered here as the balance. Rather, it is picking the location, the value in that location. Okay. And this will all work when we add this deposit okay, and other options to it. Okay, so when we meet next week, because of time, when we meet next week, oh, sorry, can you see my screen?
Yeah.
Yes, sir.
No, sir.
It's not
No,
showing
sir.
well, sir.
No, sir.
Can you see the screen?
Yes, sir. I can see.
Uh-huh. So this is where I'm saying that you can add the ampersand. That's a withdrawal function. Okay, so inside the argument, we add the ampersand here to now handle the deductions that will be made to the balance. Okay, and then that will work when we now perform the deposit, so that when we add, it will go into that particular memory location. Then when we deduct, it will deduct from the memory location, not necessarily the fixed amount. Okay, so we'll look at more of that next week. We'll look at the deposits and then the check balance aspects next week. So if you have the code, don't delete it, just keep it. Next week we'll build upon it. So now I enter my option as 2, withdraw 50, enter option 2 again, now withdraw 100. Okay, so now you can see here that what it says, insufficient funds, withdrawal what failed. You see the difference now?
Yes, sir.
Okay, so this difference is mainly because what we have, we introduced this ampersand, okay, just to handle, and you remember this from the pointers class we had when we used the pointers, okay, that this value here would actually fetch the memory, the location itself. So that it's not the value we are deducting, but we are deducting from the location. So that if we deduct from that particular location, the value will change. The value will not remain the same. And we know the balance, which is 100. So the balance will now change to 50 because we've taken 50 out of the 100 and we are left with 50. Now we want to withdraw 100. But our balance from that particular location in memory is already what? 50. So we can't go and withdraw 100. Okay. So I want you to watch the video very well and appreciate some of the things we've done today. Try them out. If you can even do the deposits before coming next week, that would be great. Okay. All right. Yes, let me take just one question because of time, and then you call it a day. Yes, Emmanuel, your hand is up.
Say please, mine is not actually a question, but say I want to see the end of your code. I just want to see the end of your code.
This is the end.
Okay, say I'm okay.
Yeah. All right. So
Okay.
I'll add this code to the LMS so that you can all see it and try out the balance, the deposits and the what's it called? The check balance. See if you can add those functions to it and then come and call them inside your switch case 1 and then case 3 respectively. All right. So please, just a quick one. Next week, Tuesday, we are meeting face to face. Next week, Tuesday, we are having our mid-semester exam. It's going to be written. Okay, it's going to be written, no coding. It's going to be written. So please, when you are coming, okay, your assessment book is already with me, so you don't need to bring official paper. Your assessment book is already with me. We'll be answering it in the assessment book. Okay, so just come, make sure you come early. We'll start with the B class. The B class will come first. That's from 7 a.m. to 10 a.m. Then the A class will come from 10 a.m. to 1 p.m. And then the part-timers will meet at 5 p.m. Okay, so we will first do the mid-semester exams. Please, if you are in a B class, make sure you come for the first session. If you realize that you are coming for the second session, you are joining the A class, you'll be penalized for that, because you'll be taking attendance based on A and B. So if you know you are staying far, make sure you wake up and come. Now we are going to do the quiz first before we transition into the what's it called? The continuation of the project, seeing the last part of the project. Okay, we have one main topic to go before exam, that's arrays. Okay, the other topic, which is on classes and objects. In fact, that is mainly what we are going to do next semester. So even if we don't tackle that topic this semester, it's our main focus for next semester. So that wouldn't be an issue. But all you need is that you understand what we are doing this sem. That's why I'm taking time to explain and uploading the videos for you to always go back and watch, because we'll be doing the same thing, basically the same thing, the same constructs, the same if-else statement, the same data type, the same loops, and so on next semester. Okay, so please watch the videos, understand, practice them. The only change from what we do next semester is the language, the change of language, but the logic, the idea is the same. Okay, so please practice them. Try the examples in the book and the exercises in the book. Okay, if you have any issue, you can see me or the TAs to help you resolve them. Okay, so please, the mid-semester is next week. We are going to have a question on a program. You'll be given a program to identify the outputs, tell the outputs like we did last week. Okay, so I'll give you a code and you tell what is the output. But by the way, there'll be no functions in the mid-sem. Okay, so you can learn all the way to loops, but there'll be no function. So there'll be a program for you to write an algorithm. There'll be a question where you draw a flowchart. And then there'll be questions where you look at the code and tell what the outputs of the code will be. Please, are we all here?
Yes, sir.
Yes, sir.
Yeah.
Yes,
And
sir.
I'm not going to. I'm not going to repeat any question. So the A class, you have your set of questions. The B class, you have your set of questions. The part-timers, you also have your set of questions. Okay, so just prepare very well so that for any question you are given, you are able to answer. That would even help so that even at the end of the mid-sem, you can now compare questions and see if you even understand the question of the other sessions. Okay. All right, so God bless you all so much. Father, we thank you and bless you today for a wonderful session. We ask that all that we've learned, you grant us understanding, clarity, and attentive memory. In Jesus' name, amen. Enjoy the rest of your day and see you
God bless you, sir.
next week.
Thank you, sir.
God bless you, sir.
God bless you, sir. Thank you, sir.
There we